Welcome everybody to activity 9.3. What does an electrical generator do? So we've been talking about electricity. We talked about circuits and we've talked about insulators and we've talked about conductors both in 9.1. And in activity 9.2, you actually created your own battery. Now we're going to talk about generators and what does an electrical generator do? So our learning target is going to be, we will investigate how electricity can be produced. And our learning goal by the end of this lesson is that you can explain in pretty basic sense. You don't have to be, super specific about it, but I want you to be able to explain the basics of how electricity is created. And hopefully you will be able to do a good job with that after this lesson. So when we think about electricity, where does electricity come from? A lot of times when I ask students this, they'll say, oh, it comes from the wall. It comes from the outlet. But how does the electricity get there? And if we were able to start following the wires, we would see that it comes from someplace other than in our house. And it's typically not right next door. Sometimes the electricity can travel for miles and miles and miles. However, if you produce your own electricity, say you have solar panels, the electricity might come from your roof or wherever the solar panels are. So we're going to talk about power plants today. And when we think of power plants, think of large-scale power plants, because some of you may have mini power plants right at your house. In other words, solar cells or solar panels. How does it get to your house? We'll talk about that a little bit today. And what does it mean to live off the grid? So first of all, how does it get to your house? So it travels through transmission lines or power lines from the power plants to your house. And when we think of all these power plants and all the factories and houses and everything that uses electricity, all this connected together is called the grid. So what it means to live off the grid is you're not connected to any outside power lines. You generate all your own electricity. So where are the closest power plants to us in Baraboo? Now, for the time being, we have a large-scale coal-burning power plant in Portage, and that power plant is eventually slated to close in the near future, in the next few years. So how long it'll be there? Well, it depends on how long from now that you're watching, and it's 2022, how long from now that are you watching this video? So that is a pretty large power plant. In fact, the Columbia Power Plant is one of the largest in the state. Now we got a couple other power plants not too far from us here in Baraboo. We do have one up by Wisconsin Dells. It's a hydro power plant. And then there's one in Sauk as well. Now when we start talking about nuclear power plants, we still have nuclear power plants in Wisconsin, and there used to be 2 of them and 3 reactors, and they're located over on Lake Michigan up north of Sheboygan. Now, as of this time, not all of them are operating, and we'll see, depending on when you watch this video, maybe they're all operating again, maybe they've been bought out, maybe they've been sold, so you're going to have to look currently to see how many nuclear power plants we have operating in Wisconsin. So we talked about the Columbia Power Plant. So if we look at a map down here, there's Baraboo, and if you drive out Highway 33, you can actually see the power plant from the end of 33. So once 33 starts curving, you don't see it anymore. But if you look straight out, a lot of times you can see the stacks that are over here. And especially you can see the stacks if it's a cooler day, because a lot of the, it almost seems like smoke coming out of the stacks, but it's steam coming out. You can actually see that from Highway 33 out here. It's a straight line. There's no hills in between. There's no trees in between. You can see those stacks. And this is what it would look like from the air, where the power plant, and just trying to think of my directions, would be just south of Portage along Highway 51. 16 is up here and it turns off to Columbus. So it's not too far, about 10 minutes outside, maybe about 5 minutes outside of Portage. So it actually has 2 power plants in one. So it's got 2 of everything there to make sure it goes. One of the things that you'll notice, a lot of power plants are located near water, and it's located next to the Wisconsin River. And that's because power plants use a lot of water as steam and to cool things. So that's our largest, largest power plant to us here in Baraboo. We do have some nuclear power plants, and these are over on Lake Michigan. And last I heard, some of these are closed, and I'd have to look and see which one exactly. But this one power plant right here has actually 2 reactors to it. And it was neat. I've been not to the power plant, but right over here in this building, they actually have a museum dedicated to electricity and nuclear power. And so I've parked in this parking lot and gone to this museum. Well, it's one of these 2 buildings, or it might be both the buildings because it looks like they're connected. So I've been into these. They wouldn't let me tour the nuclear power plant, and this was even before. This was probably about 10 years. So it was after 9/11, but it was well after that. So I took the kids there. And the other one's just located north of it. Again, nuclear power plants a lot of times are located on rivers. They're located on large lakes because they need a lot of water for cooling. The water doesn't become contaminated, but they need it for cooling. So here's again is some examples of some large-scale power plants in the state of Wisconsin. So when we start talking about a power plant, if you look at your lab sheet, you're going to see this on your lab sheet with some numbers below it. What I want you to do is I want you to be able to go through and label each of these parts, 1, 2, 3, 4, 5, and 6. And we'll talk about them, and then you'll be able to see what they are. So here's that diagram. So the first thing by, what is it, number 1, you want to label that the burning coal produces heat. So in the furnace, they burn coal. And if you think of coal, coal comes in pretty big chunks. They actually, at the Columbia Power Station, they actually grind the coal up into a fine powder and they blow the powder into the furnace. And that heat is actually used to create hot steam. And it's that steam that is actually used to spin the turbine. So that's one of the reasons why you need a lot of water. So that hot steam is under pressure, and that pressure, so it's being forced through here, and it's forced through and around the turbine, and it'll spin the turbine as it goes through. Now that turbine is actually connected to a shaft which goes into the generator. And it's this shaft right here that's spinning inside the generator is what actually produces the electricity. So the burning of the coal, the using of the steam, and then they cool that steam back down where the water is heated to produce hot steam. So when the steam is cooled back down, it forms water again and it's reheated. So they use that water over and over. So all this, the burning of the flames, the steam, the water, the cooling, the turbine is all in place to get that generator moving. And once that shaft is spinning inside the generator, you are getting electricity. Now, one of the things I have on my next slide is this right here, because I want you to know that here you're burning coal to produce the steam, which spins the turbine, which creates the electricity. This would, in a nuclear power plant, you would be using uranium to heat up the water to create the steam to spin the turbine. If you're burning natural gas, you're burning natural gas to heat up the steam to spin the turbine. Or sometimes in hydropower plants, the falling water is actually what spins the turbine. Or in a wind generator or wind turbine, whatever you want to call it, the blade spinning is what's spinning the turbine, which is creating electricity. And then solar energy is completely different. They don't have a turbine in solar cells if you got panels, but there are some large-scale solar power plants that do use these, and that's a whole nother story, but you can look that up. So make sure on your paper you have everything labeled. So again, make sure you get each of these 5 parts labeled, so that way if they're on the test, you're going to have access to them. So what I want you to do now is I want you to pause the video, and you will find a link in Google Classroom. If you don't find a link in Google Classroom, make sure you ask your teacher to get you the link. And what you're actually going to see is this apparatus right here, creating electricity. So go ahead, pause the video, and watch that video. All right, so you had a chance to watch the video. So if you went back to the video, would you be able to explain what evidence you saw that electricity was being produced? And if your answer was, oh, the light bulb was turning on, absolutely, that's your evidence. Otherwise, the person's just spinning it. You don't know if electricity is being produced, but the light shining is your evidence. So when the crank is moved, why does the intensity of the light of the bulb vary? So if you think about that, when the person was moving it really slowly, the bulb lit up a little bit. But when they're going a lot faster, the bulb lit up even more. And that's because we're getting more of those electrons to flow, which means you're getting more electricity. And then which energy transformation occurs in this demonstration? So think about that. You start with kinetic energy because the person is spinning it themselves. You get electrical energy, and that electrical energy turns to light. And then you're going to have some thermal energy from the friction of all the generator parts working, and the light bulb is going to give off a little thermal energy as well. So again, between looking at this right here, between looking at a demonstration of a generator, you should have a pretty good idea of how electricity is produced. So to wind things down, what I want you to do is go back to your lab sheet. As I go through these, you're going to have to fill in some of the blanks. So I left some of the words out on your sheet. You just have to find them on this, and you have to fill them in. So electrical energy is the energy carried by electrons moving through a conductor. This motion is called electrical current, or is called an electrical current. There are two conditions for electricity energy to be present. First of all, you have to have a closed conducting circuit, and you have to have an energy source. So we talked about both of those in activity 9.1. When you try to create circuits using things like aluminum foil, a balloon, a straw. Now, electrical circuits can transfer energy from a source to an electrical device, where it can be transformed into other types of energy. So think about that. You might have one in a power drill, and that chemical energy, you could plug it into the wall, so that electrical energy creates the circuit, which transfers energy from a source to electrical devices where it can be transformed into other energy types. Well, in a drill, you want there to be kinetic energy, so that electrical energy eventually becomes kinetic energy. You're going to get some of it as sound energy because you're going to hear the drill, and you're going to get some of it as heat or thermal energy because it's going to heat up over time. But you want it to be moving the drill bit so it drills into whatever you're trying to drill it into. Now, some more notes you can add. What does an electrical generator do? An electrical generator converts mechanical energy into electrical energy. So the electrical generators that you saw in this one, they were cranking it. And so the person actually cranked it to help create the electricity. But when you look at this right here, you could burn coal, you could burn wood, you could burn natural gas, you could have a nuclear power plant producing, energy, which would create steam. But all this steam, or if you are talking about water could be falling over, wind could be pushing. All this is creating mechanical energy by spinning this turbine. Now you got some chemical energy being created from the burning of the coal, but that coal creates the heat, which heats the steam, and that's a mechanical process of the steam spinning the turbine, or the wind spinning the turbine, or the water falling off and spinning the turbine. So now an electrical generator, again, converts mechanical energy into electrical energy, and it can be fueled by coal, oil, natural gas, wind, uranium, water, and there could potentially be some other sources such as, burning biofuels such as wood. And then if you don't already have these scientific principles, make sure you add these. So I believe they were also in 9.2. So electrical energy can be transformed into other types of energy in a closed conducting circuit with an energy source. And a battery simply transforms chemical energy into electrical energy. And a generator transformed Ke into electrical energy. So hopefully you were able to get the lab completed. Hopefully you have a pretty good understanding of how electricity is produced. Mainly, this is good because we use electricity all the time. So as always, if you have any questions about this lab or activity, please let your teacher know. Thanks. Bye.